Hello and welcome to the walking talking topic on volume question number 1 with me, Mr. Barton. Now, throughout this series of videos on volume, we're going to be covering absolutely everything, whether it's a cylinder, a cone, a sphere, the full works. And volume questions tend to appear on calculator papers, but very rarely do they ask you something as simple as just work out the volume of this or the volume of that. More often than not, it's in some kind of context or it's a compound shape or something like that. So we'll be covering the full spectrum, starting with this fairly challenging question. So we've got 12 spherical balls. Now, spherical is just a posh word for sphere. You can imagine later on are to be packed into containers. There are two types of containers available. Got a cylinder and we've got a cuboid. First part, calculate the volume of one spherical ball. Well, that's not too bad. As long as you look at the inside cover of your exam paper, you'll see that volume of a sphere is equal to 4/3 pi r cubed. Now, what's our radius? Well, our diameter is 10, so that's going to tell me my radius is equal to 5. So therefore, I'm going to do volume equals 4/3 times by pi times by my radius, which is 5 cubed. And I'm just going to tap that into my calculator. So let's do it. I have got 4/3 times by pi. So I use my fraction button then. Oh, sorry, just in case you didn't see where my pi button was, that was shift, and that's that times 10 to the x thing there. Times by 5, and get my cube to press my little x with a little square on top. Oh god, flipping heck, I forgot to actually press my cube bit in there. So that's fine, because I'll do it again here. Fractions, 4/3 times by shift pi times by 5, press me little x, and I'm going to remember to press me 3 this time. And that tells me it's 500/3 pi, but if I press my SD button, that comes into 523.5987 ... units, because it's volume, centimetres cubed. Okay, then we get to the tricky bit. Compare the total volume of empty space when 12 balls, and it's the volume of empty spherical containers, with the total volume of empty space when they're packed into box containers. Assume that the minimum number of containers required is used in each case. Okay, let's have a look at our cylinder first. Now, this cylinder has got a radius of 5.5, and our balls have got a radius of 5. So if you imagine a ball going in there, you're not going to fit more than one ball going across, because the radius of 5.5 and the radius of 5, that's pretty much going to fill it up. How many balls are you going to fit going up? Well, we've got a height of 63 there, and each one has got a radius of 5 or a diameter of 10. So that distance right the way across there is going to be 10, and I've got 63 to play with, so I reckon I'm only going to be fitting into there 6 balls going up. So I reckon I've got one ball going across, and I reckon I've got 6 balls going up, and I need to fit 12 of them. So I reckon I need 2 containers. Okay, so once I've got 2 containers needed, let's work out the volume of one of them. So volume of a cylinder is going to be equal to, and this works for any prism, it's the area of the face that repeats itself, so that's going to be pi r squared, it's a circular face, times by the height, so pi r squared times height. So pi times, what's my radius? Now I've got to be careful I don't make a mistake here. Radius 5.5. 5.5 squared times by what's my height? It's got a height of 6. So this is just going to be for the volume of one of them. Let's get this involved here. So we have got pi times by 5.5 squared times by a height of 6. Press me equals. SD that one, and I get 570.199. 570.199 ... and that is centimeters cubed. And that is the volume, I reckon, of one of these containers. Pi r squared. Oh, flipping hell, God. It's going from bad to worse here. It's not got a height of 6. I'm reading that bit. It's got a height of 63. That 6 was the 6 containers I can fit in. Tell you what, this isn't going well, this. But I'm just going to go back on my calculator to my next bit there. In fact, I'm just going to type it in again. So it was pi times radius, which was 5.5 squared, times by a height of 63. I thought that number looked a bit low. SD that's looking a bit more like it. So let's pretend that didn't happen, everybody. That's going to be 5,987.0902. that's centimetres cubed. So that's the volume of one of the containers. We need 2 containers. So 2 containers, our volume is going to be equal to that times by 2. So let's times that by 2 whilst it's in our calculator. And that's going to be 11,974.1804 centimetres cubed. So that's my volume of 2 containers. And I'm going to need both of those containers. And I've got to fit 12 balls in there. So what's the volume that these 12 balls take up? And then we can work out how much empty space is left over. So 12 balls, their volume is going to be equal to 12 lots of what I got before, 523.59 blah 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 blah. So let's clear that and let's get 523.598, I think it was, times by 12, and that's going to be 6,283.176. So I'm nearly there. Empty space is going to be equal to the volume of my 2 containers, 11,974.18 blah blah blah. Take off the volume that my 12 balls take up, 6,283.174, and that's going to give me my answer. So 11,974.18, take away 6,283.17, and notice I'm trying to be reasonably accurate here, a couple of decimal places. If I press my SD button and I'll round this to the nearest whole, that's 5,691 centimetres cubed spare. So that's from me cylinders. Flipping out, now I've got to do me container B. So container B, that's going to be a cuboid. Now let's have a look. How many of these balls can we fit into each one of these? Well, these spherical balls have got a diameter of 10. So we've got 42 by 32 by 11. So if 11's the height, that's telling me straight away I can only fit 1 ball going up. If this is the width going across, 32, well I can fit 3 of them going that way. And if this is the length going across there, 42, well I can fit 4 of them going in that way. So I can fit 4 long, 3 across and 1 high. Well, that's good news, because that's me 12 I need. 4 times 3 times 1 is 12. So I only need 1 box. That's good news. Alright, well, how do you work out the volume of a box? Well, again, it's a prism, so it's the area of one of the faces times by how far back that face goes. Or you can think of it as a cuboid, base times width times height. However you want to do it, it's going to be 42 times 32 times 11. So let's bang that into the calculator. 42 times 32 times 11. That's going to be 14,784 centimetres cubed. Okay, well, we know that we're going to fit all the 12 balls in there, and we know that the 12 balls take up 6,283.174. We got that from this previous bit here. I'll best put 12 balls in there. So, empty space. Well, that's going to be the volume of my box, which is 14,784. Take off me spare balls, 6,283.174. Let's bang that in there. So I've still got 14,784. That's good news. I don't know what that little flick is. Take off 6,283.174. And that's going to come to 8,500.826 centimetres cubed. So, which one has the most empty space? It's going to be the box. So, box has more empty space. Flipping heck, that's your opening question. God knows what's coming next. But all that comes from knowing what the volume of a sphere is, the volume of a cylinder is, and just thinking logically and using the diagrams to help you. Alright, let's see what the next question has in store.